Okay, so I'm calling this swimming into the current. A river flows 2 meters per second east, and you swim at a rate of 3 meters per second in the water. Which way should you swim to end up directly north across the river? So we have a river that's running from west to east. So let's make that north. And our river is running east at 2 meters per second. We're capable of swimming at 3 meters per second. And we want to arrive at a destination directly across the river. Obviously, if I swim forward, the current will take me and I'll end up going like this. I need to swim into the river. I need to swim at an angle kind of this way into the river, so that as it moves me, I end up actually moving with respect to the ground forward. So what we're after here is a situation where the velocity of the water with respect to the ground plus our velocity with respect to the water leads to a velocity with a direction that goes directly north. So let me draw a picture of that. Starting out with what I want to go directly north. Now, to get there, I've got water that's taking me, and I'll draw it up here, that'll be easier. I've got water that's taking me to the east, and I'm gonna have to swim out this way so that the way I move with respect to the water plus the way the water moves with respect to the ground leads to me moving with respect to the ground directly north. Now the water's moving at a rate of 2 meters per second, and I'm swimming at a rate of 3 meters per second. So all I really need to do is determine this angle here. Just be very careful about going tip to tail, and understand you must add the motion of u with respect to the water plus the water with respect to the ground to get the motion of u with respect to the ground. Or the notation I've used to write that out is the velocity of the man with respect to the ground is the velocity of the man with respect to the water plus the velocity of the water with respect to the ground. And this is actually a real easy trig problem. Our unknown angle here, that's at a right angle because we want to go directly across the river and it's running directly east. We have a right angle triangle, and the sine of this angle is opposite over hypotenuse, so the sine of theta, the sine of that angle theta is opposite over hypotenuse, which makes theta arcsine opposite over hypotenuse. Now arcsine, it just on your calculator it's going to show up as sine -1. All right, that's the function that gives you the angle that corresponds with that ratio. Or if you're using a trig table, better to learn trig on a trig table, then just find that fraction and look backwards for the angle that goes along with it. And the inverse sine or arcsine of 2 over 3 is 41.8. So theta, that angle is 41.8. So that means that your velocity has to be 3 meters per second, and then with a direction that's north, and then we're rotating, so we're pointing towards the west of north at an angle of 41.8 degrees. So that's north, 41.8 degrees west. Okay? Just again, be very careful. Remember how we set that up. I'm just going to go over drawing this triangle again, because I think if you're watching this video, you're going to have an easy time with the trig, but you might have a difficult time setting that up. So we've got a river flowing at 2 meters per second east. You swim at a rate of 3 meters per second, and you want to end up directly across the river. So I want that to be my resultant vector. So when I go tip to tail with the vector of me swimming in the water plus the water moving on the ground, I want to end up here. Also, I know that the water moving with respect to the ground is going directly this way, perpendicular to that. So I need to swim that way. So that's me in the water, you in the water, plus the water on the ground, and the result is your velocity with respect to the ground, so that you end up from this point on the river to that. Now you were given some numbers. That's a 2, that's a 3, that's a right angle, so a little bit of simple trigonometry. And that angle theta is how far west of north you are, and we write it this way. So it's like start north and then rotate theta degrees towards the west.